In this video, we'll talk about how to calculate exact trigonometric values for given angles. This will be part one of a series. There will probably be 2, maybe 3 videos in this. So just be prepared, this is part one. So before we talk about how to find exact values, let's talk about unit circles and how they relate to trigonometry. So we've talked about our trig values and related them to right triangles, but that's not where they come from. They actually come from the unit circle. So if we have a unit circle, and remember, unit circle on a coordinate plane is one that's centered at 0 with a radius of 1. Now we've kind of talked about this a little bit with polar coordinates, but not with a radius of 1. We've talked about polar coordinates as a radius of however many units away from the origin. So just to keep in mind, again, we have positive rotation. So if we have a positive angle, that's going to be counterclockwise. If we have a negative rotation, that's going to be truly clockwise. So if we look at a point on this circle, it has some coordinate x and y. And if we were to make a right triangle with this, those coordinates would line up the same way. Our horizontal motion would be x, our vertical motion would again be y. And notice, kind of like polar coordinates, there is an angle theta here. And we could say that theta dictates what x and y could be. Theta could be the independent variable, and x and y both depend upon it. As my angle changes, so will my coordinates for that green point as it moves around the circle. So if we think about this, if we can try and establish some relationships here, very similar to polar coordinates, let's look at y first. So in the case of y, that would be the opposite of the angle theta, where 1 is also the hypotenuse because we are on a unit circle. So sine of whatever theta is going to equal y, the opposite, over the hypotenuse, which is 1, which means that whatever sine of theta is, that's your y coordinate. And that would be a main takeaway for this section. I'm looking at the height, so if I'm looking for the sine of theta, all I have to do is calculate the height of that triangle. And likewise, very similarly, if we look at x, that would be, I'd want to use cosine because x is the adjacent. So cosine of theta is equal to x over 1, which means that cosine of theta is equal to x, just by itself, for a very similar reason. Now, same idea. If I'm trying to figure out what cosine of theta is, I can just figure out that horizontal motion, the x-coordinate of that triangle. And we'll go through a couple of examples here to explain what that means. So let's talk about an example here. If I wanted to find the exact value of sine of 30 degrees. Now, this one is easy enough to do with your calculator. You can get one that is exact. However, they're not always going to be nice. They're going to give you decimal estimates because they're irrational numbers. This one is one exception. I'm using it as an example to kind of show you that it is true, that our method here will work. So I want to find the exact value of sine of 30 degrees. So the first thing I'm going to do is I'm going to draw a unit circle sketch for myself. And I'm going to position 30 degrees roughly, so it's positive. It's going to go up 30 degrees. Let's say that's 30 degrees. Okay. And then I'm going to make my triangle with my coordinate. I know my hypotenuse to be 1 because I'm on a unit circle. And since I'm looking at sine, what I'm really looking for is whatever the y-coordinate is, essentially this height right here. So let me recreate a triangle here. I have a triangle that looks like this. I have one that's a 30-degree angle. Okay, and I want to know what the y is, the height, because that's what I want to know. And I'm going to do this with similar figures. This triangle is a 30-degree angle, which means that we're looking at a 30, 60, 90 right triangle. So we know that across from the 30 degrees is a side length of 1. The hypotenuse is always double, whatever that is. And then the other side, the adjacent to the 30, is the square root of 3. That would be a similar figure to this red one. So the question being, how do I get from the blue triangle to the red triangle? What's the scale factor? So right here I can look at the hypotenuses of both. That's the measurement I have, and I can use that to figure out the height. So to get from 2 to 1 with scale factors, with only division or multiplication, I would divide by 2. Which means I can do the same thing if I'm looking at the heights. How do I get from 1 to y? Well, both of these are similar triangles, which means if I divide this one by 2, I should be able to find the height. So this is telling me that y is equal to 1/2, or 0.5. And since we know that the sine of 30 is equal to whatever that height is, we can say that that is the exact value of our trig expression. So the sine of 30 is equal to 1/2. So as I mentioned before, they're not always so nice. If we're looking at cosine of 45 degrees, if you run to a calculator, you're going to get a very ugly decimal out of it. But what would it be exactly? Is there a way I can determine what it would be with a radical or with a fraction or whatever it ends up being? So again, we're looking at the exact value of cosine of negative 45 degrees. So I'm going to draw the same picture. It's a unit circle. And since we're dealing with negative rotation, it's going to go down 45 degrees. Okay? And again, we're going to make a right triangle. And since we are looking at cosine, that tells me, I'm looking at the x-coordinate. I want to find this measurement right here. Now, very similarly, I'm going to draw another triangle. And I would hope, if we're looking at a 45-degree angle, you're thinking, this is a 45-45-90 triangle, meaning that if I let the legs both be 1, the hypotenuse would have to be the square root of 2. That's a special case, special right triangle. And since I'm looking for x, I'm looking for the width or the base of this triangle, whatever terminology you want to assign to it. So again, I'm going to look at it. I'm on a unit circle. What is the scale factor? How do I get from the square root of 2 to 1? Well, just like before, I divided by whatever it was because I wanted to get back to 1, so I'm going to do the same thing here. I'm going to divide by the square root of 2, which means I'll do the same thing to the 1, which means that x is equal to 1 over the square root of 2. And that would have to equal the cosine of negative 45 degrees. Now, something that's worth noting here. This x, if you think about it in this way, it's not going to tell you whether or not it's positive or negative. Since this x-coordinate is to the right, we know we're going to end up with a positive number. However, if we were looking at, say, sine or cosine of 135 degrees, then I'd be looking more at a negative value. And that's something we'll look more at in part 2, but for now, this is how you would do it with where we're at right now. So make the unit circle, and then try and figure out what your coordinates are for that point. If you can figure out the x-coordinate, that's your cosine. If you can figure out the y-coordinate, that is your sine value.